And I would like you all to give a round of applause and welcome on stage our speaker for this presentation, Head of Chaos Engineering Harnes, Mr. Umasankar Mukkara.
Yeah. Hello, everyone. Thank you for coming over here. I'm Mukkara. So let me just talk a little bit about myself and what I do at Harnes. I'm Mukkara. I head Chaos Engineering at Harnes. Harnes is a modern software DevOps platform. We have technologies like CI pipelines, CD pipelines, cloud cost management, feature flags, of course, chaos engineering, etc., etc. I also have a history of founding a couple of other companies, Chaos Native, where I developed a project, open source project called Litmus, which is a cloud native chaos engineering project that helps increase reliability. And before that, I was doing mostly open source technologies using cloud native storage services. Litmus is now a CNCF incubating project. Some of you know that it's one of the popular projects to do chaos engineering in a cloud native way. So what is it that we are going to talk today? Right, the topic is resilient technologies. There are many things that we do to make our business services resilient, and you do very good, highly available services you deploy, and irrespective of that, you still have reliability issues. So, what are some of the things that you can do to increase the reliability of such business services, and what are some of the technologies, or a specific technology called chaos engineering, right? And before that, I will talk about why resilience is so important, and generally, what is resilience, reliability when it comes to business, right? So it's really important to understand what is resilience or reliability in a very common terms, right? So it's not like a rocket science. So people talk about resilience or reliability in many different ways. One of the ways to talk about resilience is to relate with outages, right? How many outages you are seeing in a business service. Generally, when something happens, people are not going to say that, the service is not resilient. People are going to say that there's an outage, right? So things are not available. That's primarily how your business service is talked about, right? So it's like they're always inversely proportional. When you don't see many outages, that means you're very resilient. People on the inside of the company, we always say how much reliable you are, right? So the SLAs are around 99.99, 5969. This is how we measure. But end users, consumers, measure your reliability based on how much time you're not available, right? How many outages you are seeing, and how reliable you are is basically how many outages you're not having, right? So when outages are more, you are less resilient. So the idea is to reduce the outages or reduce the amount of time a particular outage has gone through, right? So that's really how you can actually tell your end users that you are resilient, right? It's very important to see that, because when you're building an application or when you're managing a service, you always try to make it it's running all the time, but you actually never think about when an outage can happen or how fast the outage can be retrieved back or you can recover from outage, right? So in this session, I'll be talking a little bit more about outages, but that really means that you're talking about improving the resilience, right? So if you want to have continuous resilience, you want to make sure that your services are available all the time, that really means that you have to continuously make sure that there are no outages, right? So anytime you relax, an outage can happen. That's really how you provide continuous resilience. So this is like a continuous effort. Anything can happen at any time. So outage can happen anytime. That's really the reason why you have to continuously focus on resilience, right? So this is the fundamental way we need to think about resilience and outages. There are new practices that are being started in the last few years. The most common thing that you see is SREs, right? Site reliability engineering. You see, earlier we used to call IT admins, database admins, ops, but there is a new science that's becoming common called SREs, right? And SRE practices are being instilled in almost every company that's managing business services through IT, right? So SREs their main job is really to take care of the services being available or reliable, but really what they try to do is avoid outages or recover from outages faster, right? So that's really what they had to do. And why this outages, why resilience is so important is because, in order to talk about resilience importance, you can also say that why outages are bad, right? So outages are always expensive, right? Some of the examples you can see, one is like, these are both related to Fintech or finance market. So there was a pretty big outage at Wells Fargo that really resulted in significant monetary losses, and it can sometimes cause poor user experience, especially in the current fintech world. We're all going through the UPI transactions, right? So what happens if UPI is down for an hour in India, right? So your probably country's pride is affected. The user experience is so bad that everything stalls to a large extent, right, for that 1 hour, right? So it happened around April timeframe, right? So UPI services were down, and there was all over Twitterati was talking about UPI services being down, right? So it's very important. It's not just monetary losses. It could be poor credibility of your business can get affected. You're basically losing your market share to your competitors. Users are moving away from you. The more outages they happen frequently, your users are going to move away from your app to some other platform, right? So they're expensive not just in financial matters, but overall retaining the customers with you, user experience, right? So now that we established resilience and outages are really related, why do they happen? This is also kind of common sense, right? So before we go into a bit more tech. So, people continuously invest in making system resilient. Nobody wants to deploy a system where, I know there is going to be a failure when something happens, right? Outage. Before you deploy a service in production, you are almost sure that you have taken care of everything to make your system highly redundant. So you believe it is resilient. But there are continuous factors that change all the time, right? So you test in your prod. You cannot really do real testing in your prod. You can only do pre-prod or stage or dev environment, right? But in production environment, there are continuous changes that are happening. So what are some of those changes, right? So load is something that you can never match in your regular testing, right? So a bulk of users come and they change. The amount of load changes everything in your production system, right? So you can never reproduce that issue in your lab environment or user acceptance test environment, right? And we have a very good DevOps practices everywhere, primarily because you want to push software changes, right? So the more active systems, well-managed systems, they're continuously deploying software changes, right? So you're always changing your software, the amount of load is always changing. So this is a parameter why outages can happen, right? So when load increases, you don't know what you're dealing with, and something gets broken, and then that's the reason for outage, right? So similarly, software changes. We'll talk about that a little bit. And less often is these two kinds of changes. Network issues. You have highly redundant networking systems, but still, it's not that networks are gone totally nowadays, but slownesses are, common, right? So all of a sudden, your network is slow by 20%. So that can affect your end user behavior, right? And database storage issues, they need to be continuously managed, irrespective of how well you manage. These databases can start acting, a little slow when databases are full, or they're very complex systems. So things can happen in terms of total outages of the databases or slowness, right? So the other one is even more less common is hardware issues, right? Hardwares are good, they're all redundant, but still, you can expect the network switch to be gone anytime, or a network port to be gone anytime, or entire data center becomes unavailable, or a zone becomes unavailable. So these are, though less common, they're still practical. So the other important thing to understand when you're dealing with resilience is the Murphy's Law, right? You can say that it's logical or illogical, right? So it says that if anything can go wrong, it'll go wrong at some point of time. It's guaranteed, right? So anything can go wrong. So your business service outages can happen, so they will happen. It's a matter of how many nines you have in your reliability equation, right? No matter how much you do, you're still going to be facing an outage. It's a matter of an hour in a year, or a minute in a year, or 10 hours in a year, right? So that's a matter of. So we should be thinking about outages are totally not avoidable, but you can try to deal with them as much as possible. So you have to keep that in mind when trying to deal with reliability, right? So now that it's kind of an antithesis, right? So I'm saying you cannot avoid outages, right? They will happen because Murphy's Law says. So, but you're trying to improve the user experience by reducing the outages, or how fast you recover from outages, right? So how do you increase the resilience, or how do you reduce the outages? Again, it's a common sense thing. You have to do more and more testing, more practical testing, right? We're all doing as much testing as possible, but what more can you do? That's the new technology that we're talking about. So before we go into this topic of what technology can you use to do this proper testing to reduce outages, let's talk about this apps deployment pyramid, right? So you have a pyramid where most of the people are operating at your app level, right? You're always seeing your app, and your developers, your testers, your SREs, they're all looking app very closely, right? But that's still a little bit of less, there's the smallest piece of software that you write, even though, that's your focus most of the time. And at the bottom of the pyramid is you're running on either Linux or other operating system, or on Kubernetes, right? You think that's resilient because it's well tested, you've been running it, and you never actually focus on that as a developer, right? So this is the impact of outages. If your app goes down, it comes back. But what if your data center goes down, right? The impact of outage will be very, very high as you go down the pyramid, right? So similarly, API servers, message queues, and caching services, these are all thought to be reliable, but if they go down, your impact will be high, even though you have them in redundancy. both of the redundant servers can go, then your impact is very, very high. So as you go down the pyramid, the resilience rate reduces significantly, or outages, impact of outages increase significantly. So let's see, how people think about our regular software engineering practices, or SREs, right? So we all focus on testing our app. This is what we regularly do. How many SREs, or how many people test the data center some hardware going down before they say that, I'm rolling out my application into production, right? Very, very less. But if that happens, the impact of outage is the highest, though we test that to the least, right? So that's very important to understand. The most impact outage is something that you test less, and the least impact is something that you test always high, right? So we need to reverse in order to deal with resiliency. You need to change your mindset. If I'm talking about reducing outages, let's tackle the highest impacting outages first, right? So are we doing that in our regular DevOps? Probably not, right? So what's the technology that helps us, or the mindset that helps us deal with it, right? The technology that we are talking here is chaos engineering. Chaos engineering, again, is not like a new tech that people do not know about, or it's not a rocket science. It's a very simple common sense thing. We always assume that things will not go down, and we are always in a hurry to say that we lost a lot of time, let's ship it. All right, so that's we're in a hurry to do that. My test criteria is I'm finishing my functionality test, stress test, performance test, let's ship it, right? And chaos testing is a modern practice, and SREs are becoming very, very common. Site reliability engineering is coming with a pure focus of how to make things reliable. So chaos engineering is one of the tools that SREs are deploying to make these things happen. And as you can see, chaos engineering really starts at the highest impacting parameter, right? So where do you start testing the chaos testing? You really start at virtual infrastructure or a physical infrastructure, and then as you go up the chaos maturity level, you go up the pyramid, right? If you are resilient against most of the hardware issues, then you are already taking care of the maximum impact that can be occurring, right? So that's really what it is. So that's a kind of an introduction to why this resilience is important, and how outages can be avoided. Now let's actually talk in the next 5-10 minutes. How do you actually do that, and what are the tech that's available? So this is like a CNCF landscape that's available. The first two are incubating, that means more mature open source technologies. Litmus, I was the creator of that project and still an active maintainer. There are other choices for you, including the commercial choices like Harnes Chaos Engineering or Gremlin. These are some of the enterprise supported technologies for enterprises to adopt chaos engineering, right? So you've got many, many choices to start chaos engineering. Like 5 years ago, you have Netflix's Chaos Monkey. That's the most common thing that talked about. And it's not like a supported technology. You can fancy the technology, you can learn, you can feel good, and there's a lot of adoption. But now the need for chaos engineering has increased so much that there are well-supported enterprise solutions, just like any other technologies that are enterprise supported, right? For chaos engineering, you have a good tech landscape. So, and also one other common misconception is, hey, I'm also doing chaos testing. I'm doing failure testing. What is this new thing, right? Chaos engineering is nothing but you try to break some stuff and then see if it works or not, right? People try to downplay, so that's where I'm trying to explain here. Failure testing, you can always argue that it's a part of chaos engineering, but it is not the real chaos engineering, right? Failure testing is more of the engineering teams try to do a negative testing, and they're always ad hoc, and engineering test teams will not have access to the real prod environment. So whatever they do is not real failure testing. Even if they certify, that may not be like really valid later on, because in production your environment is totally different. And chaos, the SRE teams or ops teams also focus on chaos testing, more of a reactive approach. We had an outage, and then they do the root cause analysis, and then, hey, let's do some chaos testing, and they put some 5-10 test cases. Let's continuously do this failure testing from now onwards, right? You can call that as a chaos testing, not chaos engineering, right? Chaos engineering is really about making it as a practice, a more discipline of introducing faults and gradually improving your test coverage with respect to faults, which I'll talk about. So chaos engineering is always result oriented. You should be able to say that I am 50% resilient against the possible faults, right? Or I am resilient against 50% of the possible faults, right? And I have a plan to become resilient against 60% of the faults in the next quarter or 2 quarters, right? So you are basically looking at the bigger picture, and you are going after a result-oriented approach using introduction of faults, right? So that's what gives you a real good return on your overall investment, right? So let's talk about chaos engineering as a technology, right? So before you start thinking about chaos engineering, the simple definition for it is 2 parts. People always think chaos engineering is breaking something, but there are 2 parts to it. Injection of a fault is one thing, but what should happen when a fault is injected, right? So that's called steady state hypothesis validation, right? The steady state is something that's very, very important to understand, and it can change from time to time, right? So for example, when there is 10% degrade in network, what should happen, right? So 10% degrade in network, in the normal conditions, nothing will happen. Things will move on. You're good right now. But there are about 100 million transactions happening on a big Boolean day or something like that. 10% network slowdown can happen, can result in a significant business loss, right? So you lost a lot of transactions happening. So the steady state hypothesis conditions need to be clearly defined, most likely in terms of percentage of losses or percentage of transaction drops or amount of latency that you should expect, or a number of transactions, minimum number of transactions that should pass, etc., etc. So chaos engineering mandates you to think in terms of what's a written form of my business steady state is, right? So you have that very clean, clearly written idea of what those steady state conditions are, and then you start thinking about breaking things, right? Injection of faults. And when you inject a fault, you compare it with your already assumed steady state. If it's all good, then you identified a resilient scenario. So you can be sure that if such a fault happens, most likely the outage will not happen. If it happens, if it's not same as the steady state, at least you found a weakness. Now that you found a weakness, you can go and act upon it in a proactive way, right? So that's really chaos engineering. People think about it as, oh, that's it, right? So, but chaos engineering is really a culture, right? So people usually do not budget in their DevOps, strategies. People say, I have engineers to build pipelines, I have engineers to manage pipelines, I have engineers to monitor the deployed services, etc., etc. But it's started to happen now. Chaos engineering is being budgeted as part of the DevOps culture, right? So it is a mindset also. There's been some, kind of a theory that usually people are scared of introducing chaos because they're already in chaos, right? So outages are happening. how do you reduce the outages? Probably you're causing more outages by breaking things proactively, right? So it's a mindset thing that people need to understand, and it happens over a period of time, right? So there needs to be a sponsorship of the management that, okay, we have to get better, so let's actually look at the reality, let's start breaking things, right? So I will sponsor the investment to do chaos engineering. So that is the cultural shift that's needed, right? And it happens in DevOps, and it's a step-by-step thing, right? You never go from being less resilient to more resilient just by doing X things, right? It's a step-by-step process. And the other thing is to understand it's a practice, right? So practice means, we talked about results. What are the results that I should expect? What are the investment I should make? Who are the people that I should hire? And, is there a overall strategy for it? Timeline, what are my goals in the next 2-3 quarters, et cetera, et cetera. So a practice has these goals, and then you go from there, right? And it also goes through a maturity cycle, right? Chaos engineering, I'm practicing at a beginner level or a medium level or at an expert level, right? It goes through the maturity cycle. And chaos engineering never stops. You can never say that I'm done with chaos engineering, because the moment you say you're done with chaos testing, there are possibility of new changes being introduced, and there are new outages that can happen, right? So your DevOps cannot stop. Similarly, your chaos engineering cannot stop. That's why it needs to be thought of a new culture, new investment, and DevOps teams need to budget for chaos engineering if you're really serious about taking resilience, on a higher scale path, right? So some of the parameters that you need to think about when doing chaos engineering is blast radius, right? You always try to start with small faults that do not affect too many things, and slowly you get comfortable, for this amount of fault radius, I'm okay, so now I can increase, right? So one parameter is start slow faults, slow affect blast radius, and then keep increasing it. The other one is whenever you find a resilient test case, you automate it, right? So you're done with it, so that there is no new breakage that is being introduced or being leaked into your prod. And so this month you have 100 test cases that are automated. Next quarter you have 100 more, right? So the amount of test cases that you are automating will also keep increasing, and the blast radius also keep increasing, right? So through this, what you're really doing is a chaos coverage continuously increases, overall resilience scores also increase, right? And this is what we just discussed. You take one scenario, you do it well, you identify the steady state hypothesis, you test it, and you automate it, and then move on, right? Move on from infrastructure layer all the way till the application layer, right? So this summary of it is chaos engineering. You really start at the bottom of the pyramid. You go all the way till the top, and it takes time, right? It needs planning, budgeting, and effort, and you go through a maturity cycle, right? So at Harnes, we advocate our customers saying chaos goes through 4 different maturity levels, from test or start to automate to scale to expert. And at the fastest rate, you're basically taking about 2 years from start to being an expert, right? So start is really nothing but you started playing with chaos as an idea, and then you have 1 or 2 people playing with it. Being an expert, at expert maturity level, there are faults being automated. You don't know when something is getting pulled, but they're always getting pulled. You are never seeing any outage or to a large extent, right? So in an expert chaos implemented system, you are seeing faults being introduced all the time, but outages are very minimal, right? So that's the maturity model. So you have various options. You can start with Litmus, or Harnes Chaos Engineering is powered by Litmus. It's an enterprise supported product from Harnes. So you can start with any of these tools, or you have other choices as well. So, this particular product comes with a lot of ready-made, ready-to-use experiments which you can use. You don't getting started with chaos engineering is very, very easy. You got about 75 types of faults. So, at a start level, you can do basic chaos engineering within a week, right? Or within a few weeks, right? You got most of the things that are readily done for you, right? So just to summarize, what's the real return on the investment if you are investing chaos engineering as a resilient technology? You will have, the first thing that you get is how fast you can reproduce a failure, and the next one is how fast you can recover. Your recovery times are going to be drastically reduced, and overall your faults are going to be reduced, and it means that the distance between the failures will increase, right? So these are some of the examples of how a particular product, Harnes Chaos Engineering, works. With that, I think we are done with the time. Let's take some questions.
Questions?
Hi, good afternoon.
Hi.
So, if we can go back to the slide where we show the pyramid for chaos testing. So, we are saying that we are starting with the chaos engineering starts from the cloud, data center, physical and virtual infrastructure. So, what exactly do we do, assuming that all of our these products which we are deploying, these are already test based. I mean, they are baselined actually.
Yeah.
So then, what exactly do we want to
So to repeat the question, thank you. It's a good question. To repeat it, you're saying we have to start chaos engineering at the bottom of the pyramid, where it's all about cloud infrastructure, where we think cloud infrastructure is already resilient. They're all baseline. So what is it that you can do by breaking something, right? So what does, let's take AWS, right? So what they give is EC2 VM, right? Or you can get a container, right, as an infrastructure. Or you can also get a database service, RDS, et cetera, right? Or you get a VPC, right? This is the infrastructure they provide, and they're also not going to say that they are 100%, if you read those contracts, they are resilient to a certain extent, right? So as an application deployer on top of this infrastructure, you go and practice chaos engineering by actually killing that VM or killing that container or making that network slow. Instead of waiting for that network to become slow at some point of time, you have the capability to test it right away by actually losing that network forcefully, or by making it slow by X amount of percentage slowness, right? Similarly, you can do EC2 kill, you can do ECS VM kill, or a container delete, right, or container kill, or you can introduce the CPU hog, right? So, so there are various types of faults, right?
Thank you.
Any other question? I think we're done with the Q&A. Thank you very much, sir, for the presentation. Thank you.